Good evening, children. This chapter is also very important. In last video, we were discussing chapter 1, data representation, and chapter 2, data transmission. This chapter is also very important, maybe we having weightage of 20 marks. And in this 20 marks, obviously it will come of minimum 10 marks and maximum 20 marks. Then what is important from this chapter? The main thing which is important that I observed from past year papers, von Neumann architecture. The CPU architecture is very important. So this part, computer architecture, is very important for tomorrow's exam. Then all kind of storage. All kind of storage means primary memory, secondary memory, secondary memory, and cloud storage. So, and virtual memory also. So this is very important, this part. And so this is the first priority. This is the second priority. And the third part priority is sensors based questions, where IGCSE will give you some scenario and then you will discuss, you will write, you will explain how sensors, microprocessors, and ADC, DAC, actuators are working together to control any kind of system. So this kind of question. So this is the priority. And the fourth and last priority is input and output devices. And if input and output devices based questions will come, maximum of 5 marks, not more than this. Now, so let's talk about this computer architecture. So one by one, we will discuss. So you should know what is CPU. So CPU is something which process all the instruction and all the instructions and the data. Now there are two terms. One is CPU, one is microprocessor, and one is microcontroller. CPU is something which perform multiple tasks, which can perform multiple tasks or multiple instructions on large scale. On large scale. So that's why we use CPU in servers. We can use CPUs in desktop PCs, laptops, microprocessors. Sometimes we are using these two terms interchangeably. Sometimes microprocessor is also known as CPU, but microprocessor is used with to perform some limited task. Some limited task. It has some limited capacity, and it is built in a system where they can perform limited number of tasks, means in embedded system. But embedded systems means my washing machines, microwave ovens, smart ACs, air condition. So microprocessor, we can use microprocessor over there where it has to perform limited number of tasks. Microcontroller is also another thing which is used to perform specific task only, specific limited task. So the question arises, what is the difference between microprocessor and microcontroller? So microprocessor is a integrated circuit. It's a integrated circuit, and it is used to design specific task. Whereas microcontroller is something where we have the microprocessor plus RAM plus ROM and other peripheral components on a single chip. So if on a single chip you have all these components, processor, RAM, and ROM, then this structure is known as microcontroller. So few embedded systems are using microcontroller. For example, drone, some like a robotic car, something like this. So microcontroller means on a single chip, you have the processor, you have the RAM, inside this you have the ROM. But microprocessor means on a single chip, on a single chip, you have only integrated circuit, and other features like other components and like RAM and ROM are outside this chip. Now, You should know all the components. So what is meant by a microprocessor? If this definition will come, you will write it's a type of integrated circuit on a single chip. You should learn this definition, especially from your syllabus. Role of CPU, it processes instruction and data that are input into the computer so that the result can be output. So you should learn this definition of CPU from your syllabus only. Now, next question is understand the purpose of the component in a CPU. And whenever you are describing component, you have to describe all of these components: ALU, control unit, program counter, MAR, DIR, MDR, CIR, ACC, and all the buses. So, and I'm going to explain you the working of all of these components. Plus, I'm going to explain what is this fetch, decode, execute cycle. So I will explain it on my whiteboard. So first, let's quickly talk about fetch, execute, decode cycle. Decode cycle. You all know CPU is the brain of the computer. It will perform all the tasks. Whatever task you want to give to your computer, CPU is the thing, which CPU is the component which will perform all these tasks. But this process is divided into three parts: fetch, execute, and decode cycle. So what is fetch? This is the first stage of the cycle. This means where this is the stage where the instruction is fetched into the CPU. Execute means not execute, this is decode. Decode is the second stage. So I should write decode here. Fetch, decode, and then execute. So decode stage is the second stage. Decode is the stage where the instruction is decoded within the CPU. Decoded means control unit will guide the arithmetic logic unit what it has to do with the given instruction or data. Execute means this decoding is done by control unit. This decoding is done by control unit, and execution is done by arithmetic logic unit of computer CPU. This is the stage where the instruction is executed. It will calculate something. But before this, you have to understand the architecture of computer, von Neumann architecture. The main core concept behind von Neumann architecture is the stored program thing. Von Neumann architecture. Von Neumann architecture is basically behind the basic factor, the basic concept behind von Neumann architecture is stored program concept. Like nowadays in all the modern computers are basically based on von Neumann architecture, where whatever task you are giving to your computer, it will go to the RAM, the memory, the primary memory first, and then CPU will fetch all these tasks from the memory. So this means you are able to store things inside a memory. So this is the core concept behind von Neumann architecture. Your CPU is, let's say this is the CPU diagram. In the CPU, you have PC, then you have this MAR, then MDR, then CIR. CIR is actually inside the control unit. Then you have arithmetic logic unit. Inside the arithmetic logic unit, you have accumulator. So what happened? Whenever you are giving tasks to your computer, any task, or this task, this data or instruction, will be loaded to a primary memory RAM. So RAM is divided into small cells, and these data and instruction will go to the RAM. And operating system, once we are giving any task to our computer, operating system will load the address of this, load the address of the next instruction or data to the PC. So what is this PC? PC is a program counter register. PC is a program counter register. It is used to hold instruction. It is used to hold address of next instruction. And who is going to load this address to the PC? Operating system. Then this PC is connected with the MAR through one physical channel. We call it address bus. So bus means physical channel. Physical channel means maybe any wire. So this PC will send this address to the MAR, memory address register. So memory address register is a component in the CPU that hold the address of the data or instruction which is located in the RAM. Let's say this is your instruction, any instruction. And let's say the address of this place is 1AF. So operating system will load this address to PC. Then this address will go to the MAR through the address bus. And once MAR will get this address, what will happen? It will locate. MAR is connected with a RAM through a unidirectional address bus. So you can see again, this is address bus and this is also address bus. And this address bus is unidirectional because CPU is sending this address to RAM. It is not bidirectional. Address bus is always unidirectional from CPU to memory. Once MAR will send this address to the RAM, we are locating where we have this address. Once we will find this address, now the data bus will send the data to the MDR. So this is data bus. So data bus is a physical component which sends data from primary memory to memory data register. Then this 20 will come at this part. So I'm again repeating, MAR received the address and then it will find the instruction in the RAM. So to retrieve the instruction, the MAR needs to send the address to the location in a RAM. It uses the address bus again to do this. Once the address is received at the location in RAM, the data is stored in this location or instruction is sent to the component within the CPU called memory data register. This is again another register which is holding the data. When the MDR received this instruction, it sent this instruction to the CIR. The full form of CIR is current instruction register. It is current instruction register. It is current instruction register. So current instruction register is actually inside the control unit. Okay, it is example of a register in the CPU. The MDR uses the data bus to send the instruction to the CIR, and this register is in the control unit, and control unit is responsible for the next stage of the cycle that is called decode cycle. So till now I was explaining you fetch part of the fetch decode execute cycle. We call it machine instruction cycle also. So this is the first part of fetching. Fetching means operating system is loading PC with the address of the next instruction. PC is sending this data to the MAR, the address part, not data. PC is sending this address to the MAR. MAR is connected to a RAM and sending this address to the RAM so that we can find where we have this address. And once we will find this address, the data placed on that location will go to the MDR using data bus. MDR will send this data to CIR, current instruction register. This is the fetch part. Now, whenever current instruction register is loaded with this data, at this time, PC will be increment by 1. PC is incremented by 1. And what it means? It doesn't mean that we are really adding 1. Addition is happening. No. Increment by 1 means PC will be loaded with the next instructions. So address of the next instruction. And once CIR is receiving this data, we are going to the decode stage. Now, what will happen in the decode stage? the control unit in the CPU will decode the instruction. The instruction need to be decoded so that the CPU can understand what is required to execute the instruction. Basically, it is sending this data to arithmetic logic unit and explaining what you have to do with this data. Do you need to load this data, store this data, or maybe add this data, or any kind of calculation? So control unit is basically telling the arithmetic logic unit what is required to execute, and to decode an instruction, the control unit will uses a instruction set, because obviously control unit also don't know what to do with this data. So whatever data you have, this data will be it is understandable with the help of instruction set of this machine. Then by using this instruction set is divided into opcode and operand. So with the help of these terms, control unit is explaining what you have to do with this data, and then arithmetic logic unit will start execution. So once the instruction is decoded using the instruction set, it is in the execution stage. So execution stage means arithmetic logic unit will perform all the mathematical calculations and logical comparison. Whatever interim or intermediate result will come, this result will be stored in a register accumulator. So again and again, I'm using one term, register. So what is register? Register is the shortest, capacity-wise shortest and fastest storage space inside the CPU. So this is all about register. So this is the fetch, decode, execute cycle. So again, I'm repeating execution. Execution means all the calculation will be processed by the arithmetic and logic unit, ALU. It is a component within the CPU that is responsible for any calculation. All the interim values, intermediate result will may be created, and these results will store in a register accumulator. So let's quickly discuss these questions which are important. Where is data stored before it is fetched into the CPU? RAM. Which component in the CPU is responsible for making sure that fetch, decode, execute cycle is performed correctly? Control unit. What is the role of a bus? So bus is a communication system. It's a physical connection among various components of the CPU. So it's a physical connection. Physical connection means wires. Physical connection among various components of the computer. Why does the ALU need the ACC? ACC means accumulator. What would have to happen if didn't have this special register? So the ALU uses the accumulator to temporarily store results of calculations, and without the accumulator, the CPU would need to write every result back to main memory, and it will slow down the processing power. It will slow down the processing speed of our CPU. Okay, so why ALU need the accumulator? So that all the interim result, all the intermediate results of all kind of calculation can be stored in accumulator. And if it is not there, then obviously CPU has to send this result into main memory, and it will slow down the system. Now, quickly, let's quickly revise the concept, write the description of all these components. So program counter means it will hold the address of the next instruction. It will hold the address of the next instruction. And who is providing this thing? Operating system. Memory address register hold the memory location. It holds the memory location of data that need to be accessed, that need to be processed or accessed. Memory data register, it holds the actual data. It holds the actual data being fetched from or written to memory. So obviously you are fetching the instruction from the RAM, plus once all the calculation is done, then you will send back this final result to the main memory. So that's why memory address register holds the actual data being fetched from or written to memory, or written to memory. Control unit, what control unit do? Control unit controls. Again, I'm recalling one important question. Functions of control unit. 3 functions of control unit. So first function can be, it is used to fetch the data, because obviously fetch the data from the memory. So because whenever any fetching operation is happening, control unit is the main component which will decide how much data we have to fetch and at what point we have to stop. Second function of control unit can be, it is used to decode. It is used to decode the instruction, because arithmetic logic unit cannot do anything on its own until unless control unit will explain what you need to do with this particular instruction, which is inside the CIR right now. And the third thing that control unit can do, it controls the flow of data. It controls the flow of data. Now, arithmetic logic unit perform all the arithmetic and mathematical and logical operations like plus, minus, divide, multiply, remainder, all the mathematical operation plus logical means greater than, lesser than, all the comparison based result calculations. Accumulator is a special register which will hold the result temporarily and it is inside the ALU. Address bus is a physical connection which carries memory address from the processor to the other components, like it carries memory address. It carries memory address from the CPU to the RAM. So it is unidirectional. Data bus, it's a bidirectional. Data bus is bidirectional. It carries data between the processor, memory, and other component. Control bus is again bidirectional. It controls the signal from the control unit to other component. It holds the signals, control signals to among various components. Now, the next topic, what are the factors that can affect the performance of a CPU? So there are 3 factors. Cores means ALU. So if we are saying our processor is dual core, this means we are saying we have 2 ALUs, and we have 2 ALUs means we can perform 2 tasks at the same time. If you are saying your computer is quad core, so quad core means 4 ALUs. Your processor have 4 ALUs means 4 tasks can be performed simultaneously. And if you are saying your processor is octa-core means 8 ALUs, and 8 ALUs means your CPU is able to perform 8 tasks simultaneously. What is a clock speed? Clock speed is always measured in hertz. Most of the time your clock speed is gigahertz. Most of the time you can check your computer, you can check your laptop, it is in gigahertz. So you can see the size of the cache is also affect the performance of your CPU. So multiple cores means multiple tasks. So if it can process more than one instruction, it can instruction at a time. So obviously it will increase the performance of our CPU. Most modern computers have a clock speed that is measured in gigahertz. A CPU with a clock speed of 2 gigahertz can process 2 billion instructions per second. This question is very common in IGCSE. They will ask you if the clock speed is 3.5 gigahertz, what it means. So you will say 3.5 billions instructions per second. Billion instructions per second. Your computer can perform, say, 3.5 billion instruction per second. So CPU always contain an internal clock that control the speed at which instruction are processed. The speed is always measured in hertz. If a clock speed of 1 hertz means your CPU can perform one instruction in 1 second. If the clock speed is 2 hertz, so this means 2 instruction in 1 second. Now, let's quickly talk about cache. So cache is also known as SRAM, static RAM. Static RAM. Your conventional RAM is known as dynamic RAM. Static RAM or cache is based on NAND chip. Because it is based on NAND chips, that's why whenever we are sending any number of bit, we don't need to refresh it. No need of refresh after accessing any bit, unlike traditional RAM, dynamic RAM. So, and another important thing is that if your CPU is here and your RAM is here, then cache is sitting between RAM and CPU. So it is actually acting as a buffer. It is also a primary memory because it is very near, very closer to CPU, and the accessing speed is much more faster than the dynamic RAM. That's why if your computer have cache, it will obviously increase the speed. It will obviously improve the performance of our CPU. So you can see the cache is a type of data storage. Which kind of storage? Primary storage. In it store data instruction that computer uses most frequently. So how you will define RAM? RAM is a primary memory which store data and instruction which is currently in use. Same way, cache is also a primary memory which stores data and instructions which are currently or frequently used by a CPU. If the CPU can get the data and instruction quicker, the performance of a processing those instruction will improve. And if computer has a larger cache, this means it has more storage space to store the instruction. Okay. Now question, which CPU can process more instruction at the same time, a quad core or a dual core? So obviously quad core, because quad core can process more instruction at the same time because it has 4 cores and it will allow it to handle more tasks simultaneously than a dual core, because in dual core you have only 2 cores. How many instruction per second can a dual core 2.4 gigahertz CPU can process? So 2.4 gigahertz CPU means 2.4 by 2.4 billion. 2.4 billion instructions per second. Instructions per second. So if you have one core, and the speed is 2.4 gigahertz, means 2.4 billion instruction can be performed or executed per second. But if it is dual core, this means 2.4 by 2, because you have 2 cores. This means 4.8 billion. 4.8 billion instructions can be performed. 2.4 into 2 billion instructions per second. If a cache size instructions per second. If the cache size of CPU is too big, this can actually have a negative effect on the performance of the CPU. Why might this happen? So it is not always good that you have big CPU, a big cache, and it is always good. No, it is not always good. A larger cache can lead to longer access time, which makes it slower to find and retrieve data. So large or too big cache means longer access time, longer access time. So longer access time means slower to find instruction, slower to find instruction. Also, managing and searching a large cache can introduce complexity also, and it will reduce efficiency, especially when if the CPU spends more time looking for data than processing it. So long or big cache means longer access time. It means slower to find instructions. Now let's quickly discuss few questions of IGCSE questions from past paper plus specimen paper. So we have to circle three components which are the part of CPU. So accumulator, part of CPU. Hard disk, no, it is not inside the CPU. MAR, part of CPU. Program counter, part of CPU. RAM is not inside the CPU. ROM is not inside the CPU. Sensor is not inside the CPU, and SSD is also not inside the CPU. Describe the purpose of control unit within the computer using control signals. Using control signals. Second is, what is the purpose of a control unit within the computer? So the first prime purpose is with the help of control unit, with the help of control signals, with the help of control signals, control unit can control or maintain the amount of data which is carried from RAM to CPU and vice versa. So using control signals, maintaining transfer of data among various components of CPU. Another thing is that it is used to decode the instruction. And if the same question is of 3 marks, you will write the third statement. It controls the flow of data, or it take parts in fetch state of the data. What is the one purpose of core in CPU? Purpose of core is to execute the processes. Okay, so the core means it is performing all the mathematical and logical operation on instruction. Computer is upgraded to dual core. How the upgrade can affect the performance of a computer? It will increase the performance of the computer. Dual core means it can perform more instructions in 1 second. Now another paper. Let's see. A student uses a laptop and a calculator for schoolwork. The laptop has a CPU that performs the Fetch-Decode-Execute cycle. The CPU has several components, including the MDR and the arithmetic logic unit. How the MDR and the ALU are used in the Fetch-Decode-Execute cycle. So I told you, I have explained this question already. How we will describe it: data fetched from RAM is stored. Data fetched from RAM is stored into the MDR. Data from MDR. Then this data from MDR will send to the CIR, current instruction register, that it will go to the arithmetic logic unit. Then ALU will perform all the mathematical calculation, mathematical and logical calculation. Logical operation means greater than, lesser than, all the operation which will give answer true or false on the data. mathematical calculations or logical operations, or logical operations on data. Then after this calculations, ALU will send sends this data to MDR again, and then this data is sent from MDR to the RAM, so that from this RAM it can be sent to output screen. Okay, so these are the operation. Now sometimes diagram can also come. They can ask you to draw a diagram to explain only the fetch part of the machine decode cycle. So only the fetch part means RAM is here. This is your CPU. So MDR, but anyhow, MDR is taking data from the RAM using data bus. Then this data will go to the CIR. From CIR, so basically MDR is fetching data from the, or we should show MAR also, because MAR is also fetching data from PC. So MAR is actually fetching address from the program counter. RAM is fetching this address using address bus from the MAR. And once we are locating this address in the RAM, MDR will fetch the data or instruction from the RAM using data bus. Then CIR is fetching this current instruction or data from the MDR. So you can see everywhere this fetching operation is happening. From PC, address will be fetched by the MAR. RAM is fetching this address from the MAR. Then whenever we will locate this particular address in the RAM, the data at that particular location will be fetched by the MDR. Whatever data you have in a MDR, the CIR will fetch this data, and then this data will be fetched by the arithmetic logic unit. So arithmetic logic unit is taking this data. So this is all fetching operation. So here you will label them, that whatever I have explained, you have to label them. You have to write steps. You have to label this thing. Now, if so this is the example of fetch stage. This is the example of fetch stage of cycle. You can see the very first instruction is MAR is fetching the address from the PC. The second stage is the RAM is fetching the address from the MAR using address bus. Third stage is the MDR fetching the instruction with the help of data bus. Then the fourth is the CIR is fetching the instruction from the MDR to be decoded. And this is the fetch stage cycle. So same way we can show the execution stage of the, this is the diagram of execution stage. So control unit will activate the ALU, because control unit will decode the instructions, and it will explain the ALU what you have to do with this instruction. The second step is operands are fetched. Operands means that hold some data. ALU perform the operations. It is a third operation. This is the third step. The result is stored in accumulator. So you can use term accumulator here. Then flags are updated if applicable, like if it is an interim calculation, so we can set the flags. And if the flag is showing some special stage where this is where it is showing it's a final stage, then we will send the data from the accumulator to MDR, And from MDR, this final calculation is again go back to the primary memory RAM so that we can send this final calculation to the output screen. You can see in all the papers, it is 2023 paper. Every time they are asking question from the von Neumann architecture. The student uses a keyboard to complete the schoolwork. Which type of device it is? It is input device. Printer, it is an output device. A component in the CPU sends signals to manage the signals. If something is sending signals, means it is control unit. It is control unit. Then a CPU has a clock speed of 2.4 gigahertz. So if clock speed is 1 hertz, this means your CPU will execute one instruction in 1 second. But if you are saying that 2.4 gigahertz means 2.4 billion instructions per second. Okay, so CPU can perform 2.4 billion instruction per second. Then CPU contain register including the memory data register. Describe the role of the MDR in the fetch, decode, execute cycle. So what your MDR is doing? MDR stores the data. It stores or hold data that has been fetched, or fetched to, or to be written to memory. Memory means RAM. Identify 3 other register contained in the CPU. It can be PC. It can be PC means program counter, current instruction register. ACC means accumulator. MER means memory address register. So you can write any thing here. It is another paper from IGCSE. What is meant by clock speed? A user computer has CPU with a clock speed of 2 gigahertz. He or she wants to change it to the 3 gigahertz. So what is meant by a clock speed? So basically clock speed is the number of cycles. Number of cycles means fetch, decode, execute cycles. Execute cycles the CPU can carry out per second. It is usually measured in gigahertz. So what is clock speed? It is number of fetch, decode, execute cycles the CPU can carry out per second. What is the effect this change will have on the performance of the CPU? So if you are increasing the clock speed, this means your CPU can process more instruction. Before it was processing, like before this change, it was processing 2 billion instruction per second. But if you are changing the speed, this means your CPU can perform 3 billion instruction in 1 second. So CPU can process more instructions per second. Okay, so basically this will improve the performance of the computer, and it will allow tasks to be completed faster. So program will obviously run more smoothly and the system will be more responsive. However, it is possible that it can also lead to increased power consumption. It is possible that your CPU will consume more power and it will generate more heat. It is also possible. So the positive impact is that CPU can process more instruction in 1 second per second. And the negative impact is that it will take more power, the power consumption is high, so that it will produce more heat. Okay. Now, the CPU contains a memory address register. Describe the role of the MAR in the fetch, decode, execute cycle. So, MAR holds the address of the instruction or data to be executed by the CPU. It sends this address to the RAM, and via the address bus, so that CPU can access the required instruction. So this is the role. This is the role. MAR is fetching the address from the PC, so that from the PC means program counter register. Then it will send this address to the RAM, so that via the address bus, so that CPU can access the required instruction or data from that particular address. Then this is another component of 2023 IGCSE paper. 3 components that are built into the CPU: accumulator, control unit, program counter. ROM is not inside the CPU, RAM is not inside the CPU, motherboard, hard disk, graphic card not inside the CPU. CPU is a cache. So what is cache? Cache is a primary memory. It can store data and instructions which is like frequently used by the CPU. So it is faster. It is faster than DRAM, dynamic RAM. That's why it can speed. So what is the purpose? The main core purpose is that it will speed up. It will speed up the performance. It will speed up the performance of your CPU. But this will give you only 1 mark. If you want to get full marks, you will say cache is a primary memory which is located between the RAM and the CPU as a buffer. It stores frequently used data and instruction. It is because it is faster than dynamic RAM. That's why it can speed up the performance of your CPU. This should be your final. This CPU has a component that regulate the fetch-decode-execute cycle. So again, control unit. Control unit is responsible for regulating the number of instructions. The CPU has a component that carried out all calculations, means arithmetic and logical unit. Now let's see this question. The program counter, it's a register, contains the what? Address. It contains the address of the next instruction to be processed. This is then sent to the MAR, memory address register, using the address bus. The address is then sent to the RAM, so that we can locate where we have this address and what data it is containing. Once the address is received, the instruction stored at the location is sent to the MDR, memory data register, using the data bus. The instruction is then sent to the current instruction register that is built into the control unit. So this is the answer of this. So you must have a full knowledge about all these register. Register is smallest and fastest storage space inside the CPU. You should have a knowledge of all the functions of control unit and all the functions of arithmetic logic unit. The CPU uses an instruction set to decode the instruction. So what is meant by an instruction set? It a set of commands in machine language, machine code, we can say. This is the set of commands. Okay. So please subscribe my channel if you like this video, and you can write something in your comment if you want more content on any topic. You can write me in the comment section. You can press the bell icon if so that you can get notification about new content. Thank you.